In example 4, we again start by identifying the interior function, which in this case is 3 plus t to the 6th. We'll take the derivative of both sides of that substitution statement, which in this case is in terms of t instead of x. But the derivative would be the same, or would follow the same property. So this would become 6t to the 5th. And then multiplying both sides by dt would give us 6t to the 5th dt. So with that interior function, we have our statement u. And then if we look at the rest of this, which is a little split up, that's 6t to the 5th and the dt at the end. Those pieces combined can be swapped out for du, leaving us with the integral of u to the 6th power du, not dt. So again, we've rewritten our integral in terms of a new variable u, and our result is something that's much simpler to integrate than the original problem. So this would integrate as u to the 7th over 7 plus some constant c, and then we would replace u with 3 plus t to the 6th to generate our final result. In example 5, our interior function would be this 2x minus 5, which is being raised to the negative 2nd power. So we would make our substitution and then take the derivative of both sides. So we know that du is equal to 2dx, so we can use that 2 out front combined with the dx at the end to swap out for du, which would leave us with the integral of u to the negative 2nd power du. So again, we're left with something simpler to integrate, which in this case would become u to the negative 1 over negative 1 plus c. We could replace u with 2x minus 5. And then rather than leave that negative 1 in the denominator, we could just write this as negative 2x minus 5 to the negative 1st power plus some constant c. In our last example of looking at these simpler cases of integration by substitution, the process again remains pretty similar. We'll identify the interior function, so in this case we have e being raised to some more complicated statement. So we'll let u equal 1 minus 6t. Taking the derivative of both sides will give us negative 6. So du equals negative 6 dt. So in terms of negative 6 and dt, we'll be able to swap those out for du, leaving us with the integral of e to the u du. So that will integrate as e to the u plus c, or e to the 1 minus 6t plus some constant c. So in each of these first six examples, we identified the interior function, let u equal that statement, found the derivative of both sides to swap out the remaining pieces of that function. So those would be considered the simpler cases of integration by substitution. What we'll look at in the next few examples, these trickier substitutions, are cases where this statement du doesn't directly equal something that's left over in our problem, and we'll look at what we would do to proceed from there.